Hello, everyone, and thank you for joining today's webinar on Creo Simulation Live. We're excited to show you how this tool can provide real-time feedback on your design decisions by embedding simulation directly into the modeling environment. Before we get started, just a quick reminder to submit your questions anytime in the Q&A panel. If we don't get to your questions during the presentation, we'll be sure to reach out with answers after. Now, I am pleased to introduce today's presenter, Senior Applications Engineer Todd Liebenow. Let's get started.
To get started, I've got a few slides, then we'll actually get into the technology I'm anxious to show you today. But first, some questions. What are we trying to do with simulation? What's some of the reasons that we might want to consider simulation on a product? Well, I'm not going to read you the whole slide here, but some typical things that we hear is we want to get a better understanding of how the product is actually going to perform in use in real life. Maybe we want to shorten production development cycles, right? Quicker time to market. That's always a big push, is to get the product out the door, designed more quickly and delivered to the customer. So reducing the cycle times. And something that we often hear is reduction in prototypes, right? Instead of building something in real life, we can do a digital simulation on that, usually faster and cheaper than we can actually going out to the shop and developing, cutting parts. And even with 3D printing, there's advantages in doing a digital prototype before you even get to that point where you want to make a 3D printed parts. What about warranty, liability, right? So we want to decrease our exposure to those types of things. So if we do simulations up front and early in the product development process, we can typically get to a better product more quickly. What are some of the challenges that go along with that? Well, again, if we think about how this typically happens, oftentimes simulation needs to be sent to some other department or even outsourced to another company. Consultation with an expert to do that simulation. And oftentimes you can't use the actual design model. It needs to be simplified or some sort of defeatured or detuned so you can actually do sort of the digital prototyping. And that takes time and effort to go ahead and do that, right? It's you design complex parts, and then if you have to sort of detune and back out of that to do a simulation on that, that's extra effort. And then if we think about the product development process in general, it's usually a loop, right? We're usually designing something, testing something, building a prototype, and then we say, oh, this worked, but this didn't, or maybe we want some better performance, right? So this is a very iterative process that we have to step through. So to address that, we've got a portfolio of tools from PTC, specifically in the area of simulation. So it's a pretty broad spectrum. I'm not going to go through all of this today, but we're really going to focus on the Creo Simulation Live aspect of the tool set. We've done and we'll do other webinars on the other tools in the simulation portfolio. But again, today we're really focused on the early in the design process simulation, and the tool that really addresses that the best is Creo Simulate Live. So that came online as of Creo 4, date code M90, as you can see there, and that's powered by ANSYS. So that's a result of the relationship between PTC and ANSYS and the integration of the tools together to give us access to this simulation toolset. So kind of stole my own thunder from this slide here, but the PTC and ANSYS partnership really is best in class in simulation tools and product development tools, CAD tools, bringing those tools to the desktop for the engineers so they can have those design and development and simulation tools right at their fingertips. So how does this fit into the process? So if we think about the simulation, when does that typically happen? So typically in the design process, you can do simulations and product development. Oftentimes you'll do that just to try and get an idea of, is this going to work? Is it going to fail? What if I try this? What if I move a feature, change some geometry, something like that? Gets to be sort of a process to do that. And oftentimes it doesn't happen, right? So Creo Simulate Live is really built with that intent and purpose in mind to give us instantaneous, virtually real-time feedback on our simulation and product development process. So the analogy I typically use here, and you might have heard this before, is comparison between a compass and a GPS. So Creo Simulate Live is going to give me accurate results. I don't mean to say that by thinking of it as a compass, it's not going to be accurate and precise. It is. But it's generally useful for looking at trends and ideas and trying things very quickly and giving me a general direction as to where to go. Whereas the GPS might be more along the lines of a Creo Simulation, Creo Simulate Advanced, or Creo ANSYS type application, where I'm able to do high fidelity, accurate simulations, and I can do things like sensitivity and optimization studies and things like that, where I really want to hone in on a specific aspect of the simulation to make sure that I'm getting optimized results. Creo Simulate Live is early on in the design process, where I can do my what if studies very quickly and easily and iterate through a lot of different ideas very, very quickly. So you might say, well, what's the need for both, right? So there's a bit of an overlap there. And you can see that Creo Simulate Live has capabilities that cover a lot of different areas of functionality. So we're going to cover that here in the demo that I've got coming up for you. Structural, vibrational, thermal, and flow analysis can be included in Creo Simulate Live. And again, it's useful for ideation, concept simulation, and then there's a bit of an overlap there when we want to think about things like more detailed design refinement, validations, optimization studies, and those types of things. When I'm trending in that direction, I might consider Creo Simulate or Creo Simulate Advanced, or the other applications from ANSYS, the mechanical or the ANSYS AIM application for that. The focus is where or when to use this in the product development process, and Creo Simulate Live is purpose-built and intent to be used early on in that product development process. Bit of a summary of the functionality. I mentioned this a minute or two ago, right? So down at the bottom, you'll see the capabilities cover the spectrum there of structural, thermal, vibrational, and flow type studies. And the idea there is that I want to get quick feedback without a lot of complexity in setting up a simulation and worrying about convergence and mesh refinement and all of those types of things. And I want really zippy performance. I want to get that feedback on my design, pretty quickly, virtually instantaneously, as quickly as I can. And I also want to have confidence in the results, right? So just because it's fast, if it's not accurate, then it's not worth the effort. And that's certainly not the case with any of the ANSYS applications. So we're definitely getting accurate results there. But again, I'm looking for trend lines and those types of things relative to the performance of my model. So some summary bullet points as to why Creo Simulation Live, right, helps me understand my product performance envelope. It speeds up the development cycles, helping me get to market more quickly with those designs. Looking at making fewer prototypes, because I've done more prototypes digitally, and so I don't have to spend time and money cutting parts and assembling things and those types of processes. I can do that virtually and digitally in my Creo session. And obviously, if I can make better products that are more robust and perform better, I can look at reducing my warranty and liability exposure as well. So a bit of a deep dive on the capabilities. Again, a few slides here, and then I will get to the technology and show you what this looks like. So we're looking at a linear solver that allows me to do the things that are mentioned there, the structural, thermal, vibrational analyses. And we're actually using the video card here as far as the parallel processing and using a little bit different approach to the simulation. So if you're familiar with FEA in general, right, you're probably familiar with the different mesh types, whether that's traditional H-type elements or the adaptive P-type elements in Creo Simulate. We're doing something a little different here, where we're sort of discretizing the model and then using the video card to do some parallel processing on the volume that is included in the part or assembly, and then doing our simulation on that. So we don't think in terms of mesh refinement. There are capabilities to allow me to control the speed and accuracy of the results. Basically, just a slider that allows me to toggle between the different ranges of the solution that I want. But it's automatically converging to results there based on the level of performance and accuracy that I specify in my model. So I don't necessarily have to think about, oh gosh, did my model converge? Is my mesh fine enough? Do I have singularities and have other things like that that I need to consider? Because again, the idea here is to use this tool quickly and get that feedback right away from the simulation, rather than having to go to a much more complicated type setup. If you need those types of simulations, hey, again, Creo Simulate or Creo ANSYS can help you out with that. Of course, we're running inside the Creo Parametric environment, right? So this runs seamlessly. We don't have to fire up another application. We basically just toggle into a new tab that says Live Simulate, specify your simulation, the design study, whether it's the structural, thermal, vibrational, or flow type analysis, and you can build out your simulation there. And you can have multiple simulations inside of the same model, right? So all of that stuff lives basically inside of that model. And then you can just toggle into a structural or a thermal analysis as the needs may require. And you know, just basically toggle on and off the simulation so you can see what happens in real time. And it's automatically going to be continuously computing those results for you on the screen, right? So you basically turn the simulation on and off as you want to see the results. A little bit of an eye chart, but basically just a summary of the capabilities inside of Creo Simulate Live. The primary thing here to note is if you're looking at the flow type studies, that's going to bring you into the Creo Simulate Live Plus type capability. But you get sort of a snapshot there of the different types of simulation modes and the capabilities that you have inside of Creo Simulate Live. Again, some different comparisons here between the different modes. What happens when you're looking at Creo Simulate versus Creo Simulate Live? There's some considerations there when we think about how assemblies and those types of things are handled. You have interconnections between components where you have bonded and contact type interfaces between components, and you have that same kind of capability inside of Creo Simulate Live to allow you to address those assembly type considerations. As I mentioned a couple minutes ago, the solver runs continuously in the background. You can toggle on and off as you want to make changes to your model, and we'll show you what that looks like live here in just a minute, the software. Hardware capability, I mentioned this a little ways back where it's utilizing the NVIDIA graphics card. And so there's a little application you can download from ptc.com just to check and make sure that you actually have sufficient hardware. It does need to be an NVIDIA board to do that, and there's certainly different levels of supported hardware for that. They say 4 gigs is sort of a minimum, and I would say that'd be a bare minimum as a recommendation, and obviously more is better on that. And so you can make sure that you have the appropriate hardware to solve the models and get the performance that you want for those simulation runs. Looking at the results, this is just sort of a summary slide. We'll show you what this looks like when we actually get into the different variations of the models that we'll look at. But you have ability to toggle into the different display types. So in a structural analysis, you have different things you can look at, like deformation, different types of stress, principal, von Mises, thermal studies. You can see the temperature and heat flux, for example. You can look at different mode shapes and frequencies in a modal analysis. And you can change the display type there as the different types of analyses are created. So depending upon whether you're looking at a flow type simulation, you want to look at particles or streamlines, you can do that, or you can look at temperature distribution, pressures, velocity, those types of things as well. And you've got the ability to kind of change the item that's being displayed and the temperature scale there, if you will, on the legend, so you can modify that and interact with that to get the results that you're looking for. And obviously, you might want to put down a little digital probe and measure at certain discrete points in the model. You can certainly do that there with the dynamic query. Go ahead and toggle the location you want, or you can drop a probe and have a persistent tag there that shows the value that you're interested in as a saved analysis in the model. And of course, you might want to export that back out, and there's an option to create an HTML report for use later on, right? So if you want to capture the information, share that with other people, you can generate that HTML report to share with other people on your team. Again, hardware requirements, we'll just kind of blast that up there for a bit. This might be a little bit dated as far as hardware, but of course, PTC.com is always going to have the latest information, up-to-date supported hardware platform information relative to graphics cards and memory on those cards as required. Okay, so enough of the PowerPoint. We'll go ahead and toggle out of that. Give me just a second here. We'll transition into showing the software. Okay, so at this point, we've got an assembly pulled up in Creo. And so in this case, we've got a number of components that are put together in this assembly, and we'll just show you what this looks like here in Creo Simulate Live. Just a quick walkthrough, right? So the different types of simulations that we have here are available in the dropdown. I've got the full license, so I've got the ability to do the structure, thermal, and modal or vibrational type studies. And then the Creo Simulate Live Advanced, right? So that's going to be this option here as far as the flow type studies. The other thing I would show you here is when we're actually in the study, you have the ability to toggle the performance, right? So you have just a slider here that takes you between a higher speed, quicker to run simulation as opposed to a little bit more accurate, right? So you have the ability here to just use that slider to toggle between the range of the simulation quality that you're interested in, right? So you can go ahead and just modify that as needed. So what do we have? In this case, we've got our simulation objects turned on. I've got this it's not a casting, but it's an assembly for part of a snowmobile frame. So we've got our boundary conditions here. We're grabbing onto that inner surface of that casting, and we've got some loads applied to different regions of the model here. We want to go ahead and run a simulation on that. We've got a structural simulation in this case, and let's just kind of take a look at what we have. So here we have the constraints that I've defined, right? So at those locations, I just mentioned that before. We'll just kind of toggle through what this looks like in the model tree. We've got a couple of different loads that are applied here, right? And so we're just basically saying, here's what we're doing. We're using these items in the ribbon to define the constraints. We've got fixed or displacement type constraints, mechanism type constraints here, very similar to what we might have in Creo Simulate. And then different types of loads, right? We can look at things like force modes, loads, moments, pressures, gravity, centrifugal loads, and linear acceleration. So in the structural mode, these are the types of loads that we have. When we toggle into the different types of simulations, obviously the boundary conditions are going to change, so the ribbon will change slightly based on the type of simulation that you're running. And so we've also got a probe out here, which is basically a summary, a measurement that was taken during a simulation run. So you can go ahead and start the simulation, and we're going to get pretty much real-time feedback on this as far as the simulation. Now, if I go ahead and turn off the simulation display, all that's doing there for me is turning off the boundary conditions. In this case, we're looking at a deformation, and I can animate that just to kind of give you an idea of what that looks like as far as the deformation of that model based on the load that we've applied. Okay, so we can do that, and then we'll go ahead and stop that for right now. And the different items we can look at as far as results from the structural simulation are here. If we want to look at a von Mises stress distribution on that, so I can kind of see how the model is going to behave based on that load case. And we can go in and take a look at the different, the fringe plot here. In this case, we've got the display of von Mises in terms of kilopascals, and so we've got other items here as far as local reaction forces, reaction resultants, and other items that we can look at as far as different types of stress on the model. So pretty straightforward as far as looking at that. And as long as I leave the simulation turned on, it's going to go ahead and leave that fringe plot display on the model for me, right? So as I go ahead and work with the model, if I wanted to turn that off, I certainly can. And it's basically going to stop that continuous computation of the results. But I can toggle in and out of that as needed. Okay, so how do we actually set some of this up? Now, if we wanted to look at a discrete part from the structural simulation standpoint, we can do that. And same as before, we'll go into the live simulation. In this case, I've got a structural simulation, and let's go ahead and turn on the items that I've got set up here in this model. So very similar to what we've done before, instead of looking at an assembly, now we're looking at a discrete component. And just like we've done before, I've got my boundary conditions, right? I've got a constraint here at that inner cylindrical surface where the shaft goes through that casting. And then I've got a load applied up here to these three cylindrical locations where that's actually attached to the rest of the frame. We'll go ahead and do the simulation on that. And for comparison, this model, you're going to see this run pretty much in real time. So I'll just kind of, talk over the top of this. Within about, maybe 10 seconds, 15 seconds or so, I get the results on that model. If I was going to run this same model in Creo Simulate, right, it's about a 4.5-minute run on a single pass adaptive with the same load case, same boundary conditions, same geometry, same everything. So you can see, the difference between Creo Simulate Live is, 10 and 15 seconds maybe, as compared to a 4.5-minute run. And I'm going to get basically the same results, right? So the same type of results as far as the display of items that I'm looking at, whether it's deformation, von Mises, or the other different stress components that I'm interested in. I can go ahead and get that same type of thing. So the idea is I want to do a quick turn on my simulation and just understand what's going on here. Am I going in the right direction? Well, what does that actually mean? So I'll leave the simulation up, and if I went back and said, you know what, I actually maybe want to put a little rib in this area right here, right, to see if I can help stiffen that model a little bit. Well, we'll do that. We'll go back into the rib function. We'll drop in a trajectory rib. Notice that the simulation pauses for me, and I'll go ahead and just use that sketch that I've set up for that rib sort of ahead of time as concepting things. I'm just going to go through and toggle some options here. We'll turn on the rib. We'll add some rounds to the top and the bottom of that feature that we're going to drop in. We'll go ahead and accept that. And then in real time, you'll see that feature regenerate, and then the simulation starts all over again. And in real time, it's going to compute those results for me with the addition of that new geometry. So again, this is the compass aspect of Creo Simulate Live, where I can do very, very quick turnarounds on ideas and concepting of what if I add that rib? What if I take it out? What if I change the width? I'm doing what if studies on my model, and I get very, very quick results that tell me, hey, am I trending in the right direction? Is this a good idea, or should I maybe potentially do something different? So that's really the power of Creo Simulate Live, is that allows me to do those very, very quick turns on my design iterations and concepts without sacrificing quality of the results. So that's one of the first models I was going to show you. So a couple of different scenarios there for a structural assembly simulation and a discrete component simulation. We go ahead and take a look at some other options here just to kind of take you through the rest of the capabilities in the Creo Simulate Live functionality. Just as long as we're in structure, let's go ahead and take a look at this, right? So in this case, I'm in Creo 12, and so there's new capabilities in Creo Simulate Live that allow me to look at contact between the components, right? So what happens in this particular scenario, you can see I've got this plate that's sort of riveted together on top of that, and I'm constrained on either end. You can see the load that's applied to the top of that. I'll toggle off the simulation result or the components right now. Now, if I just go ahead and start that, right, you're going to see that it's going to show some results and then they're going to kind of go away, right? Well, what's happening there is there's no awareness of those components relative to each other. They're assembled, right? But they're just assumed to be sort of bonded together, right? Unless I do something different, right? So what is that something different I need to do? I need to define a contact between those components, right? And so what that's telling me is in real life, I know that I'm going to have that bolt that's attached to the top plate and holding those two items together. Well, what I need to do is basically say, hey, I'm going to go back and automatically detect those contacts. So then that's going to more accurately simulate what's going to happen in real life, where now I'm actually got those items that are going to be basically bolted together, and you see quite a bit of different result there, as now things are actually going to be clamped together, and the contact interrelationship or interface between those components is now correctly captured. So now I can see that's what I should expect to see from that simulation, because the model is now actually tracking that contact or the relationship between those two bolts, the top plate, the bottom plate, and the little nut that's holding things, or rivet that's holding things together at the bottom. So that's some pretty cool stuff in the structural simulation that PTC's added with ANSYS in the newer versions of Creo Simulate Live. So go ahead and close that. Let's open up another model here to kind of flex some of the other items that we're going to look at. If we look at a vibrational type study, we're interested in finding out the natural frequencies and the mode shapes of something. So this would be sort of an engine valve cover, right? And so what I've done here in this case, I've defined, there's no loads on this necessarily, but what I've done is I've actually sort of constrained the bottom surface of this. We toggle that on. Oops, I want to hit my display items here. I'm fixing the bottom surface of that, right, as if it's attached to the top of the engine block. And I want to see how that might actually vibrate based on how that's the geometry is defined, and the material it's made of, and how it's actually attached, right? So now what we're looking at here is the deformation of this, right? So this is basically looking at how that's actually going to move based on its geometry and how it's clamped. And this is the first natural frequency, and it gives me the mode shape and the frequency. And if I animate that, let's see kind of what that looks like here. Let's actually show that thing kind of moving around. Right, so there we can see that's the first natural frequency and mode shape that's going to, how that model is going to bend and deflect based on its current configuration. We take a look at mode shape 3, we can see other parts of the geometry going to be moving around now based on the natural frequency, and we see a little bit different value for that, the cycles of that. Let's go take another look at, say, mode shape 5, for example. Now we can see that that's actually going to behave a little differently. So again, we get an idea of how this model is actually going to behave when it's bolted onto that engine block. These are the different mode shapes, how it's going to actually vibrate, and the frequency it's going to vibrate at, based on, again, the geometry of the material and how it's actually constrained in space. So that would be an example of a modal type analysis. Let's go ahead and take a look at some other options here. Just kind of wheeling through, let's go and take a look at a thermal analysis. In this case, we're going to look at an engine that's got several different components on it. And just like we did before, we'll go ahead and look at our boundary conditions for this. So we go into live simulation, and we can see here it looks kind of furry, but what that really is the boundary conditions where we actually have convection conditions on the outside of the model. That basically is simulating if air is going to be moving over the top of that. I can control the temperature and the characteristics of that. When I go ahead and solve that, right, what this is going to do is show me what that model looks like as far as the heat being transferred. Oh, so what we've done is we put in heat load on the top of this engine block up here. I didn't actually call it out, but this top surface up here is going to be where the heat load is actually applied. And I can see how that engine block is going to actually dissipate heat based on the geometry and the boundary conditions of the connections between the components that are in that assembly. Now we have items here as well as far as contact, and what I've done is basically just say right now, this lower portion of that engine block, the casting is actually bolted to and connected up to that. If I wanted to change that, I can go back and edit the definition of that and say right now it's bonded, but if I said that's free, that basically gives me a perfectly thermally resistive situation there where it's not going to transfer any heat to the lower portion of that. And what happens now, you can see that basically perfectly insulated the top half of the engine block from the bottom half. And that's an example of where those different contact connections between the components exist, right? So I get to control what actually happens in that model. This probably isn't real life, but this might be where you'd start the model and say, oh gosh, that's right. I need to make sure that I actually connect up those components and make sure that I understand how the heat's going to flow from the top half of the engine block into the lower half. But again, that would be done with the contact connections or interfaces between the components. But there's a little bit of a taste of the thermal studies in Creo Simulate Live. So lots of stuff coming at you today. A couple more models to look at, and then we'll kind of wrap things up here. So let's go ahead and take a look at one other example from the flow standpoint. If we take a look at this race, well, let's do this one, this muffler example. So in this case, this is a muffler off of a motorcycle. And so what we've done here is basically define the internal of this. Let's actually go here and show you what this looks like from a cross-section standpoint here first. We'll go ahead and turn this on. So you can see the internals of this muffler, right? So, and we've got the intake of the muffler here. It flows through the center portion of that. And then we have the baffles and the other structure inside there. So you can see what it looks like inside of the muffler. So go ahead and just turn that off right now. Right, so go ahead and just turn that like that. Okay, so we can just leave that on. But if we go into Creo Simulate Live and actually look at what we've got going on here, in this case, we're looking at a flow type study, right? So we're down here creating a fluid simulation. And in this case, what we've done here is specified the internal volume of that, basically capturing automatically using a seed and boundary. I've grabbed the inside geometry of that entire muffler assembly, and that becomes the fluid volume. And then inside that fluid volume, I'm going to specify that as carbon dioxide, right? So I'm specifying not just the volume, but also the characteristics of the fluid, in this case, carbon dioxide coming from the engine. That's going to be what we're pushing through that muffler assembly. From there, we have our boundary conditions. And so we're specifying a flow inbound on this end of the muffler at 85 inches per second, and outbound on the exit side of the muffler at 0 pressure, and basically at atmospheric pressure. And I can also specify, in this case, I've got an inlet temperature of a prescribed temperature of 700 degrees C. So again, we've got hot carbon dioxide coming off the engine, flowing through the muffler. And then we want to see what's actually going to happen with that in our flow analysis. So we go ahead and take a look at that. Now we're going to go ahead and take a look at this. In this case, we're looking at the velocity as it's flowing through there. And we can see it's actually calculating that for us in real time. You can see the flow is inbound on this side, flowing through the muffler, and it's calculating that for us continuously in real time. So that's what the velocity is going to look like. We turn that off, and then maybe we want to see the streamlines and show what that actually is going to look like inside there as it's kind of swirling through the muffler. You get an idea of how that flow is actually going to go from the inlet side through the restrictor plate here and through the little ports into the larger expansion chamber of the muffler, and how it's going to swirl around in there and then finally exit on the tailpipe on this side there. And if you wanted to look at particles as it flows through there, you can get an idea about what that looks like there as far as the particle flow through the muffler. In that case, we're looking at velocity, but if we wanted to look at temperature, you could look at that as well, right? So I don't think I included any convection conditions on the outside of that muffler. So it's basically a constant temperature as it flows through. But if I had included the convection or forced convection over the outside of that muffler, I would probably see a decrease in temperature as it went from the inbound side to the exhaust side. You should see a cooling or drop in that temperature as it flowed through the muffler. there's a little bit on the flow, and you can go ahead and actually put a section through there to kind of see what's happening through the inside. So if you wanted to kind of see the swirls and see the flow as it actually transits across the muffler, you get an idea of what that flow looks like inside there. So that's an example of an internal flow, and I think the last one I would show you here today would be an external flow, because it's cool. Oh, it's all cool. But in this case, I've got a race car, right? So I want to look at the fluid flow on the outside of that. And what I'll do here is just kind of walk through what's set up here. In this case, we're looking at air, and I've defined the fluid volume here, right? And my boundary conditions for that, if we take a look what's going on here with that, I've got an exit pressure. So again, it's atmosphere, so it's basically going to be zero pressure. And then on the three sides of the box here, we're going to have basically a slip symmetry, which basically just means, you know, you can kind of safely zero out what's happening there, because what really is happening is we've got an air velocity that's moving across from the front of the car towards the car, and then underneath on the ground as the car is moving forward at what are we looking at there? 20 meters per second, right? So that's my initial conditions. And from there, if we go ahead and run our simulation on that, we've got a section plane kind of started up there. If we want to see what's happening on that, you can kind of see what's happening there. And if I want to go ahead and drag that around, I've got tools that allow me to look at my resulting objects here, and I can just kind of drag this thing around and kind of see what's happening through that section of that plane. Right? You can turn that cut direction off. And this one's pretty nifty from the standpoint that we'll turn our contours off and turn the streamlines on. You can see what's actually happening there. In this case, we're looking at temperature, so it's pretty constant. That's not so interesting. Let's actually look at velocity. And I can see what's actually happening as the car is zipping down the racetrack or down the road. You can see how the flow is actually going to, you know, stream around the side of the car. And if we go back to our results objects, I can actually toggle this thing around. Let's actually move that so I can see what actually happens as the air swirls around that little spoiler on the back there. Give me the downforce to make sure that the tail end stays attached to the track as I go around the corner. So pretty much real-time results here as I'm looking at the model, and I can kind of drag this thing around and change what actually is happening and see how the flow is going to go around the car as it moves across the track. So there's kind of a nice walkthrough of structure simulation, vibrational simulation, thermal simulation, and internal external flow using Creo Simulate Live.